Okay, we first go through the we first go through the uh, functions, and then we go to the pre presentation. First, we use PCA, and we use 40 people, and each people have 5 pictures, and the dimension is 5 to train the data. After the training is done, we will use a test to get the result. This is the highest accuracy I get for the whole project. This is the 2D PCA result, then the PCA result. Also 40 people and 5 people and 5 faces of each people. And this time we use 20. This time we use 20 dimensions, which means 20 vectors. After training is done, this is the normal recognition accuracy, 84%. Then we use the Fisher's method. Fisher's method, we choose the image and we'll compare itself. First image is the test image, and the second image is the original training image. We can see that there's a little difference between the two images, but it's the same person. And then we use Haydn-Markov model. In this model, we first train the Haydn-Markov model with the with the parameters as shown above. These parameters. After training, we will do the test. We can see that the result just a few seconds. The result is in 100% is 85%, so the accuracy is above the is acceptable. Then we go on the presentation. First, this is the final project for 6825 pattern recognition. My project title is Comparison of Face Recognition Algorithms. And as we all know, face recognition is very popular nowadays. As for the background information, let's show the steps of the face recognition. First, this is a very simple and easy to understand way to get to acknowledge some fundamental information about face recognition. The first step is to recognize get the human face, of course, and recognize it. And then the second step of the algorithm will find the critical points of the human face, such as we show in the first picture: the ear, the eyes, and the nose and the mouth. The third step is the face alignment, which means we will represent the image into another image or another matrix. The last part is the human face specific feature detection. In this part, we will get the specific different kinds of features of different people and align them into different groups. Mm. And for the facial identification part, we can see that the for example, the facial identification is first image is capture the image, then align the eye locations, and after that we will convert the original image to grayscale, and this is the better way for us to uh, do the simulations. Then we will use this. Uh, then we'll then we will match match the image and search the image using the sophisticated algorithm to compare the template of other templates in the database. And finally, we will get the exact class of this image, of this person in the image. Uh, in this project, I used 4 algorithms. 3 are successful, but the Fisher's method is not is not complete. This is the example of the project as I just shown before in MATLAB. PCA is a principal component analysis. It's a widely used analyze method for different kinds of uh, functions. In this project, the PCA training is uh, the algorithm is used the principal component analyze with the SVM, the principal component analyze with support vector machine, and the diagram shown below is the training part and the testing part of the PCA algorithm, and also the 2D PCA algorithm. First of all, we get the initial face image database and compute the face vectors of each person. Then we calculate the covariance matrix and get the agent values and vectors to determine the agent faces. Then we store the uh, most significant agent vectors to do the get the training result to get the training result. Then we calculate the weight according to the above agent vectors. Uh, then the training will be complete, or if not, it will go to the start and do it again. After the training is complete, we will doing the testing part. The testing part will get the face image and compute the face vector. Then then we will use the training vectors to determine the Euclidean distance between the testing vector and the training vectors and find the and then we will find the minimum distance, Euclidean distance, and determine the phase class, which of the phase class the test image is in. If it is not determined, then it will go to the start and do it again. This is the this is briefly the PCA and 2D PCA algorithm. Then the PCA result is shown in the table. As we can see, the largest value is when we use 5 images for each person, and the vectors is and we use 40 vectors, which means there are 40 dimensions. The result is 89%. 89% is is not is not is acceptable. Then the 2D PCA result, as we can see, 2D PCA will use less vectors. We can just use five dimension, which means 5 vectors to get the uh, best result, 91 and 5%. Then the Haydn-Markov models. The Haydn-Markov models function is the algorithm is shown in the diagram. We of course we first get images, then use DCT transform to get observation sequences. Then we will initialize the parameters in Haydn-Markov model. Then use Viterbi segmentation to segment the images, and then we will use the segmental k-means to calculate weights. If the result is convergent, we will complete the training. If not, we will go to the beginning to do the segmentation again until the result will converge. This is the result of the Haydn-Markov model. As we can see, the best performance is increase with DCT number at first and then decrease, and it is increase with the overlapping region and then decrease. So we determine the best location of the accuracy is overlapping region of 7 and the DCT number of 9. The result is 85%. Generally speaking, the project successfully simulate the 2D PCA, PCA, and the Haydn-Markov model. The Fisher's method is not complete because the recognition rate is very low. That's all. Thank you.